Welcome to Chibuzor Mathphysics. In today's video, I'll be taking you through matrices. Matrices are simply a set of numbers arranged in rows and columns so as to form a rectangular array. Matrix is being used in mathematics, in physics, economics, in statistics, engineering, and various other branches of mathematics. So let us dive into it. I'll be taking you through various types of matrices and their importance. I remain your friend Gallagher. Subscribe to this channel so as to be notified in our subsequent videos. Stay tuned and enjoy. The very first type of matrices that we are going to talk about is column matrix. A column matrix is a matrix with single column, and this is called a column matrix. For a column matrix M, the order is M by 1. What we simply mean is that a column matrix is a matrix with only one column, and all the elements are arranged one below the other in a vertical line. So the matrix column is represented by M by 1, so it has only one or a single column. Let me give you an example of a column matrix. When we talk about column matrix, let's take an example for a column matrix. So we've got column matrix in this form: A1, we have A2, we have A3, up to AM. You can have AM. It is represented in a vertical line. This is what we call a column matrix of the order M by 1. So this is the very first type of matrix that we might talk about. The second type of matrix is row matrix. A row matrix is a matrix with a single row, and this is called a row matrix. For a column matrix M, the order is 1 by n. The order is 1 by n. So for a row matrix, it is represented in a horizontal line. So example for that will be A1, we have A2, we have A3, up to AN, So this is a row matrix, and it is good to pay attention to this so that as we dive into calculations and arrangement of matrices, we are able to use this, apply this in our calculations. The third type of matrix is the square matrix. A square matrix is a matrix with an equal number of rows and columns, and this is called a square matrix. In this case, we can say that M number of rows will be equals to n number of columns. So let us take an example of this type of matrices that we call square matrices. So for a square matrices, m number of rows must be equal to n number of columns. So we have A11, we can have A12, we have A13, up to A1n. We also have A21, we have A22, we have A23, up to A2n. We have A31, we have A32, we have A33, up to we have A3n. We have AN1, we have AN2, AN3 up to ANN. Of course, before we have AN1, maybe we have another element here, another element or entries into up to this before we can have that. So this is what we call a square matrix, because the number of rows must be equal to the number of columns. So this is a square matrix. Let's take another type of matrix. The fourth type of matrix is what we call the diagonal matrix. If the non-diagonal members of a matrix are 0, then that matrix is called a diagonal matrix. So in linear algebra, or even in foundations of mathematics, a diagonal matrix is a matrix in which the entries outside the main diagonal are all 0. So the term usually refers to square matrices. Of course, the element of the main diagonal can either be 0 or non-zeros. But when we talk about diagonal matrix, if the non-diagonal members of a matrix are 0, then that matrix can be referred to as a diagonal matrix. So let us take an example of a diagonal matrix. So for a diagonal matrix, let's say that we have A11, we have A11, we have 0, then we have 0 up to 0 here. We have 0, we have A12, this is A22, we have 0, then this will also be 0. So this is 0, this is 0, here is A33. Of course, this is 0. We have so if you observe in these entries, you can see that all the non-diagonal members of this matrix are zeros. The diagonal element of the matrix is A11, A22, A33, ANN. So this is the diagonal members of this element, and we can see that it contains some element. But apart from this diagonal, every other element in this matrix is 0. So we refer to this kind of matrix as diagonal matrix. So let us consider another type of matrix. The fifth type of matrix is what we call the identity matrix. Identity matrix, it is a square matrix with all diagonal members equal to 1 and non-diagonal members are zeros. So let's take example and see how that. So let's have 1, we have 0, we have 0, then we have 0, we have 0, 1, 0, then 0, we have 0, 0, 1, then this is 0. Of course, here we have these ellipses, that is in case there are other matrices, and here will be 0, 0, 0, then 1. So if you observe all the diagonal element of this matrices are 1, while all the other the non-diagonals are zeros. This is different from diagonal matrix, because diagonal matrices, we observe that in diagonal matrices we have elements in the diagonal while all other elements are zeros. But in the identity matrix, the diagonal elements are 1 while the non-diagonal members are simply 0. So this is what we call an identity matrix. let us consider another type of matrix. Now the final matrix we have to deal with here is what we call transpose of a matrix. So far we've covered 5 types of matrix. We've covered the column matrix, the square matrix, we've covered the diagonal matrix, identity matrix, and then now we have to deal with transpose of a matrix. What is a transpose of matrix? The new matrix obtained by interchanging the rows and columns of the original matrix is called as the transpose of the matrix. So transpose of a matrix A is denoted by AT, A power T. We call it A transpose or A prime. If you can't put T there, just put prime. So if A is equals to Aij and Ij is in the form of M by N, so the A transpose will be Aij, and the transpose now will be in the form of N by M. I want you to note that. The first element is A M by N, but the transpose will be N by M. So let us take an example of A transpose. Let's have example of this. So example of A transpose. So let us transpose this element. First of all, let us write the order. So the order of this matrix is order 3 by 2. It is 3 by 2 because we've got 1, 1, 2, 3, then 1, 2. That is how we count order of a matrix. So let us it means that this have got M by N. So the result of this will be N by M. So let's see how to do that. This will be 3, 5. So we will have 3, 4, 4, and then we have 3, 4, and 9, and then we have -5. We have -5, 7 over 2, and then 5 over 8. 5 over 8. With simply interchange the rows and columns so that this will be our new matrix, and this is called A transpose or A prime. So this is the order. It is now order 2 by 3, which is equal to N by M that we have here. So this is how we transpose matrices. Of course, there are other things that we need to know in terms of matrices. Let me mention one or two things that we need to know as we conclude this video. Let us take properties of properties. These are properties the properties of a transpose matrix will be given by every A transpose multiplied by the transpose matrix must give you A. That is to say, if you transpose a matrix multiplied by that matrix that you transpose, you will get the formal element, which is A. So this is number 1 property of a transpose matrix. Another property is that A plus minus B transpose will be equals to A transpose plus or minus B transpose. Another property is that if you multiply A transpose with a kind of scalar quantity Ka transpose, this will give you Ka transpose, and this will be the 3 properties that we have in terms of transpose matrices. I remain your friend Augustine Chibuzor. Catch you in next video as we do with now computations, calculations in terms of matrices.